Is my screen visible?
Yes, sir.
Okay.
Yes, sir.
So I'm assuming that what are the things that I showed you in previous sessions, rather you must have tried them, and like there might be some questions in your mind. I don't know whether you had it or you have it about like few things which you could not understand. So if there are any questions, you can ask me. You can raise your hand if there is any question. Okay, otherwise we'll continue with what I'm expecting to add some additional information about the systems. Okay, so I'm adding a code. Right, so say it is hash include stdio.h hash include. We talked about this file yesterday, unistd.h. Right. Let us write the main. Say integer I into ABC. Suppose this is our one code. Anytime if you have any questions, you can definitely ask me while I'm not speaking ultimately because I'm typing the code. So if you have any questions, you can stop me in between and you can ask the question if you have any. Okay, now we have these three functions. Fine. Now, is there any dependency in these functions? Main is calling ABC, ABC is calling PQR, PQR is calling only printf. Right? But we already saw printf execution would not be shown to us. But ultimately, like the thing that is happening, let us open a spreadsheet. Yeah. So this is our main program. Okay. This is ABC. This is PQR. So let us say these are the lines. This is your main. Fine. And this is your PQR to show exactly. So we don't, let us not care about how many lines are there. Okay, in the code. Fine. These are the three different programs that we wrote on other terminal. Main. Say right now I gave names as 1.c, 2.c, and 3.c. But ultimately main, ABC, and PQR. Let us try to talk about them this way. Fine. So now what happens is what happens is here. Okay. So suppose this is the place where there is a call. Let us say add a color. This is the place where call to ABC is. Correct. Now what should happen if we try to address it? C shape line. So this call would be executed. This call would be given. Okay, and after execution of that function, is the return point. Okay. So I assume this is visible. Let us make it arrow. I'm creating a drawing for you people. But this is how the picture is, correct? Now suppose this is the place where call to PQR is. Same case. So this is called to PQR and this is return. Correct? This is how the picture is now currently in terms of our code that we had. Correct? In main, we are calling something. Correct? And then ultimately, when the call is given, we will be processing the code and the code will be getting executed. That's what the picture is. So if I try to see this way, see, this is main. This is main. Main is calling ABC. ABC is here. ABC is calling PQR. So this is main. Main is calling ABC. This is ABC. This is PQR. So one can write here ABC. And this is PQR. So I'm making it fancy so that it would be visible to you. Yeah. Okay. Now, what care is to be taken by the system to have this kind of communication there? So when my execution starts from this point, line number 1, line number 2, line number 3, line number 4, line number 5, everything is sequential now. Right? When it reaches here, then suddenly there is a call, then it goes here. Then it is going to execute this. Suddenly it sees there is a call. It passes control here. It executes this. When it reaches here, again it gets back to this line. It executes this one, then comes back here, and then it executes this one, this one, this one, this one, this one, this one, done. Right? This is how our understanding is. So we say sequential execution. So sequential execution was happening here. Sequential execution is happening here. This is a jump. It is passing the control from this execution point to this execution point. Again sequential. This one, this one, this one. Now again jump. Again sequential. But when I say sequential, actually there might be again different calls. Now imagine this picture as a hierarchy, a tree. If I rotate this file, right? Rotate, I mean to say, suppose I tilt, say for a while, my screen. Right now, I could not do that, but think of this, like if I have drawn this picture and if I rotate that page, say by 90 degrees. So it will look like there is a hierarchy. This might be root. This is child. There might be hundreds of such childs there because every line could be a function call here in my main code, correct? In currently, what are the main code that I have? I have printf call, I have ABC call, I have printf call. 3 calls at least are there, correct? So let us save there. Yes. Okay, we are back to terminal. Now let us try to compile this. GCC-M32 1.c -c. Okay, GCC 2.c, GCC 3.c. Now if I see file 1.0, file 2.0, file 3.0, all are 32-bit LSB relocatable, and each of them now you can see as not stripped. So if we see, sorry, size is 1592, 1562, 68, and 1500. Each one of them is having. So if I apply strip, we already saw that to discard symbols which are not necessary. So if I now fire this, you can see the change. Ultimately double to what we had, approximately double to what we had earlier in the generated file. So there would be some extensive bytes or memory locations occupied unnecessarily. Do you require them? Probably no, but they need to be there. And even if I remove them, execution would be definitely done. I don't care whether they are there or not, because whatever is necessary can be seen here in these 3 files. Okay, so let me link them together. GCC-M32 1.0, 2.0 and 3.0. So this is a linker. Now it is saying what? Undefined reference to main. Now let us check. Let's 1.c. We wrote main, correct? So if I write GCC 1.c dash M32. Now it is telling us there's a function called ABC. So let me do this 1.c with 2.0. Then it says, do you have really ABC there? ABC is added here. Ultimately, yes. But was exactly my file got created. So instead of doing this, let me write 2.c, 3.c. My executable got generated. If I execute this, you can see we are in function ABC, we are in PQR, and after execution, stack for this function will get destroyed. We are back to ABC, we are back in main program. Let us try to debug this. Let us display the addresses, registers EAX, EBX, ECX, EDX, ESP, EBP, ESI, EDI. These all are 8 general purpose registers used by your Intel architecture for 32-bit machines. Now, when you are talking about 64-bit architecture, they also are part of their system, that system as well, being treated as a 32-bit one. So let us set breakpoint. So let me display another registers too. This is program counter EIP. So EAX, EBX, ECX, EDX. This is in like if you see in CO kind of course, you must be told, okay, this looks this works as an accumulator. Correct. This is stack pointer to control the system stack. This is base pointer, and this would be treated as a stack pointer whenever a stack frame gets created for the function. Listen carefully what I said. EBP would be used as a base pointer, but will be used as a stack pointer whenever a stack frame gets created. Now let us see how exactly stack frame gets created. So I assume we set the breakpoint. Let us run. Now see, we are in main. Let me write BT. There is only one stack right now, correct? Let me say step. So currently we are in main program. See the values. This minus 0, this EBX was 0 before executing the code. When my printf would be getting executed, when main started executing, some values got changed. So EX, is it remained same? Yes, you compare this value and this one. EBX, yes, change. ECX also changed. EDX, I could not see any change. ESP, yes, there is a change. EBP, again there is a change because I am going to use this printf call. That's why this is internal stack created now. ESI, EDI, they remained same. EIP, instruction pointer was at main, now it is going to execute main plus 33. Okay, let us write step. Again, your instruction pointer changed to 100. These two values remained same, 90 and 8. These two also remained same. These all are changing mostly, except this EBX. So whenever a call gets executed, understand this. Whenever a function call gets executed, EAX, ECX, and EDX are bound to change. Have you heard what I said? Are bound to change. They should always get changed. EAX should be storing return value for that function. What is the function call which was given? EAX should be holding return value of that function. Now it is going to execute ABC. Correct? Let us say step. Now we are in ABC. So if I write BT, you should see another stack got created because we are in ABC. And now you see here, you were in main, your pointer was here. Now it is inside this function body ABC. It doesn't have any information about that. But if you see here, this is 90, this is 8. This became 8C. So if I try to say examine contents of ESP, what is the address? 565562050. What is this? 200. So probably let us see this. Like if suppose if I come back from stack after executing that ABC, I should get some value here in between this 200 and probably 205. Let us assume this. Let me say step. Now it is inside ABC. ABC is giving call to PQR. Now again see this for PQR. Correct. So we will try to see what is value at this 70. Now this got changed. Another stack frame got created because PQR is under execution. Now your instruction pointer also is pointing to this line. That means it is now currently here. It is executing this code. Are you with me? Yes, please.
Yes, sir.
Okay. So let us move. Now, if I try to examine again contents of ESP, X means examine at value at memory address. What was it? 256. So if we go up, this was 251. Correct? So when the call was for this PQR, when it entered the PQR, before that some value was stored and it was this 250. Now compare this value. 56556 256 56556 256. So if I go up, yes. See this stack. Now we don't have address here, but we do have 205 and see this 205 stack. This was a stack address which was hold for main. That means it is telling me this is the return address. You have to go there. That's where your stack starts probably. Next top would be there. Correct? You can map this number. Like this is not shown here because current stack will have 0. It will have name. It doesn't have address. Same thing can be seen here. We saw address for earlier function. Current address is not shown. But definitely that address probably somewhere here because we are working with PQR. So if PQR is having any call, let us say, let us go further. Now if I write BT, because printf is not going to get executed at that level ultimately. And I would be getting information about the system where current execution pointer is, and this is what it is telling me. This current execution pointer, which would be the next instruction that it is going to execute. And it displays it here. So if I say step, if I write BT, I can see 3. Now remember this. Now what will happen when we are at return 0? When curly bracket occurs, this will get destroyed after that curly bracket. Now instead of PQR, only ABC would be shown without this address. Okay, let us check this. Step, I will write BT every time. Still PQR. Now we are at curly bracket. Correct? Step. Now concentrate on values. A6 to 59, 60, 70, 68, 88. Everything got changed because now we are in ABC. So what happened exactly? We executed this function Now we are in ABC here. So we got here now at this point. Correct? Now we have to execute this remaining part of this PQR. So let us say step PQR. I mean to say sorry, ABC. I mean to say ABC. I have to execute this ABC step. Sorry, step. Step. So if I write BT, again 2 stacks, address is gone. Step. I'm at last point. Now currently 2 stacks are there. Now when I execute this curly bracket, what will happen is this ABC stack would be getting destroyed. Let us see this. It is gone. Now it is back to that address. It was 205 if you recall. Now its next address is 208, which is to be executed. This is the one which it wants to execute now. Address of this printf is currently here, 208. Now let me say step. It got executed that point. Now it is at return 0. That's what it displayed here. We are back, like earlier statement, we are back to ABC. Now see again the values. ESP, EVP. These would be the prior values. So remember these values too. Okay. So step. We are executing curly bracket. Step. So if I write BT, only one stack. Step. Now we came out of main. Now we entered into this function, which exactly was giving call to main. If I see BT, see this address and sorry, this address and this address. Is it same?
Yes.
And there exactly the call was for your main function. At this address, there was a call to main, which was given call earlier, and we executed that call. Now it is returning back to this stack, original system stack, where these 2 stacks are added by your execution environment. So while on shell you wrote gdb ./a.out, ./a.out got executed. It was given space in memory, and address where exactly your underscore start got loaded was this. And this was calling somewhere libc start main. And libc start main is the current stack. Now you may say why it is not showing us directly that the way that it was showing PQR or ABC. Because this is systems area. There is a boundary line between us. Me to be kernel area, you to be user area, which you might have heard somewhere in OS course, okay, while you did your bachelor's. There's some area which is controlled, reserved for the system. You cannot enter into. You cannot make changes here in these places. You can change only make changes prior to this, before executing that last curly bracket. You do whatever you wish inside. Definitely, it should be a fruitful thing. Am I right? Okay, so let us say step again. Done. Everything got collapsed. Everything got executed. It came out of it. Came out of the system. Understood now this picture? What the picture that I tried creating in front of you? How the control pass happens? Okay, let me tell you. You might have heard a terminology called context switch. Have you heard this in OS? I assume you passed OS course in your bachelor's, probably 3rd year, with assumption that you either did BCA or BSc Computer Science. Have you heard about this context switch? This Friday, I think Zund movie is going to get released, and I'm going to go there. Now, I don't recall exactly who are the actors, but whatever I heard about that movie, I'm going to see that. Now, suddenly you might have started thinking what exactly I did here. why I suddenly started talking about the movie. So some of you maybe can open up and you say, okay, also I'm planning to do so. Now I switched completely the context. My parameters, my register values got assigned to this current context now, the context that I'm speaking about. Okay. Now then suddenly I ask, where were we? What we were discussing? You might have experienced this one inside the class. Then return address is found. Yeah, that was the point that we were discussing. How the control passes from one code to other code, and from this code to another code. Now here we created only hierarchy of two programs, where first like three programs, where one is the main calling others. Luckily, I had these three as three different files. What if they are in single point of single contents? Single content, I mean to say, in a single .o, if all of them are included. Yes, that also would be similar picture. Only thing that this will be available somewhere here below this. This will be available somewhere below that. Is that okay? Any questions? Any questions?
सर ते विदाउट मेन कंपाईल कसं काय झालं?
No, there is a main. Na? We wrote main. Place one not C.
Sir, in 2 and 3.
So we linked it. We linked it here. You can see the line that I used is this. GCC 1.c, 2.c, 3.c together. Now if I try to do this separately, now your problem, what you are trying to tell, correct? But as I'm linking this together with 1.c, because 1.c is calling a function which is defined in 2.c. 2.c in 2.c we are calling a function which is defined in 3.c. So we all together use them in a single command to generate an executable. I could have done this also. Let us do this. Yeah. Now let me do this. 1.c, 2.o, 3.o. This also is possible. Okay, let me delete for you star.o, rm a.out, dash ltr. You have 1.c, 2.c, 3.c. Let us generate object code 3.c, 2.c, and now I am using these object codes to link together with my main code. Then I can see an executable what created. Is that fine, Tushar, now?
Yes, sir.
Okay, so we did actually linking. Now what happened there? Yes, that's what I said. We would be talking about this. Linking करना मतलब क्या करना होता है? Linking means you are not going to link only codes. So if I see nm 1.o, sorry, 2.o, 3.o, gcc dash m32 1.c dash c, 1.o, 2.o, and 3.o. There was a global. We declared here k in 2.o, if you could recall, because we wrote return k in this code. We declared it and we said return k. It is not of use at all, but I wanted to show you that I took a variable which was global is added there. Now if I write this nm a.out, we have to find out pqr, printf, correct, abc, main, and k there. Let us write less. One can see ABC is there. Okay, then do you see any other thing? No. Let us move further. We got K. Yes. It is in BSS because we haven't given any initial value to it. Correct. Then main, then PQR, and then printf. Sorry, this one. Correct. So they are all added. So if I write even readlf dash s 1.0, see this main and ABC and printf. Right now it is undefined because it is not linked. We are talking about only 1.0, 2.0, K and ABC and PQR. Correct. And 3.0 only PQR and printf. Are you with me? I hope you understood this picture now. For you, it is taking how much efforts to create your executable. What is to be done? Okay. When it reaches here, you translate this line, this line, this line, this line. You reach here. There's a call. You pass control here. Generate executable. Execute this executable. When you reach here, pass the control. Execute this one and come back and so on. What is the big deal? No. There are too many things involved. We have to allocate space for this code, complete code, executable. This should be in memory. This would be in memory. But is it dynamic? So that would be static. So if I see my obj dump output, sorry. Let us see there if I can see PQR ABC definitions. PY SYM, DY STR. Yes, so now somewhere we should get them. Our function bodies, user defined functions. Now main, this is your main code. This is ABC. Code is added itself because it was a static code. Yes, it was for even PQR is there. Correct. That means what happened was exactly when the file was created, this was added as an object code. This was added as a part of object code, and this also got added. So your executable is containing now this whole big size. This completely your executable. Here we are seeing it as a partial perspective because this is what you can call it as not dynamically linked. Printf was dynamically linked. If you see, while we saw that printf there, you saw UND undefined. In this 2.0, PQR is not defined because PQR is available in 3.0 or 3.c. That's why it is UND. Printf also UND. That would be linked after the linking. But currently, my file contains reference to it as undefined. Even if I write this, a dot out pipe this. See whether you are seeing printf there. See, it is still undefined. But PQR, ABC, let us see them. We saw ABC defined. Okay, we can see PQR defined, but only right for me they are undefined because they are library. Everything which is UND would be linked after linking. This address, this would be resolved after we see the executable generated. After linking time binding is done. Then only I would be seeing that this is resolved. Right now, I would not be able to, I'm not in a situation to see that. But if I write even this one, still I can see UND. When it reaches to that point where the printf is used by you, then control should be passed to the explicit library where my printf is defined. So how my printf is defined? This is my printf defined as extern. This is a definition header file. Now it definitely would be part of some library like libc. If I say correct libc.so.6. Now let me show you this. GDB dot slash dot out bt point main run l. You see this. It is defined there libc.so.6. This is a library. So suppose if I copy this, symbolic link to this library 2.31.so. Okay, let us use this one also. So it is available here. So lib32. Now see, it is a shared object. Now in Windows, you might have heard a terminology called dynamic link library. Have you heard this? DLL? Have you heard about DLL? Siddhi? Siddhi Bhosle. Ketan? So I assume it is not the case that you cannot speak. Purva, can you speak? Am I audible? Or you are asking only Tushar that Tushar should talk, not others? That means neither of you is understanding what I'm trying to tell. So should I close this session then? I want everybody probably from tomorrow to switch on your videos too. Okay, otherwise I will stop the class. Because whenever I'm asking questions, nobody is responding. Only Tushar is not supposed to answer my questions. Amol, are you there? Kathare?
Yes, sir.
Okay, any question? See, don't care about the language that you are asking question to me. You can use any language, not a problem. Because I cannot judge now you peoples whether are you really with me or you're only you have only started this one and you don't want to respond. Whether you are with me or you are not with me, whether you started this session and you left the session in between by keeping mobile on. I cannot understand this. So until unless you say something, I will not start.